Greetings and welcome to Lesson 4 of INTL 644, Cyber and the Intelligence Cycle. In this lesson, we are concentrating on the processing and analysis phase of the intelligence cycle. We are going to be looking at a number of things related to processing and analysis. The center of gravity, if you will, for this week's lesson is big data, because big data actually addresses each and every one of the course objectives. Big data is relevant to the challenges of the cyber domain versus traditional domains. Big data overlaps the military and commercial sector. And the technology is advancing perhaps more quickly than the ability to deal with it. And lastly, big data has some very specific legal and policy implications, mostly related to privacy. Processing and analysis in the cyber domain is a two-edged sword because we learn about ourselves and our enemies at the same time. Intelligence, particularly in the cyber domain, needs to be collected and processed across disparate military and commercial systems. The internet is, as we've discussed before, borderless and a jumbled combination of hardware, software, and logic. The amount of data is growing at an incredible rate. And as a result of that, the term big data was coined. One way to look at big data is in the traditional definitions, which are noted here on this slide. We have the structured data that found in a logical manner. Example include files, records, and so on. And then we have semi-structured and unstructured. Now, I suspect that when you think about this, it's as confusing to you as it was to me when I looked at it. And so I did some digging and looked at big data from the perspective of what vendors are in it and how are the products being marketed to deal with the big data. So the applications include industry applications or vertical applications. Then there are applications that deal specifically with data logs, one of the leaders being Splunk, S-P-L-U-N-K. Then there are various media applications such as media science that look at big data from a media perspective. The most well-known application is probably business intelligence, with the three leading vendors in that world being Oracle, SAP, and IBM. Another equally big marketplace is analytics and visual. In the academic world, SAS has been a leader. And for those of you who are familiar with the intelligence community, Palantir and their proprietary software is very well known. Four other segments that are appropriate are the analysis segment, with Hortonworks being a vendor in that group, the operational infrastructure, Terracotta and Informatica, vendors there, and infrastructure as a service, with Amazon Web Services being far and away the biggest. And last but not least in this kind of analysis is structured databases such as Oracle, SQL Server, and IBM's DB2. So that is another way to look at it. You can also think of it as big data is built by a variety of sources: databases, data warehouses, enterprise resource planning, customer resource management, audio-video files, Excel files, CSVs, comma-separated variables, social media, and various logs. The big data pool would then have to be converted into reports and dashboards and specific inquiries from the analytical perspective. Sources of big data include logs, sensors, traffic monitoring analysis, and as we talked about a little bit last week, security information and event management. I mentioned analytics because analytics is key. You have this giant pile of data, and you have to have the ability to pick out what you need for the intelligence analysis and work product at hand. Unfortunately, when you have big data, you need a fair amount of computing power to go through it. The computing power is required because the data is stored in large storage arrays and because the manipulation requires a lot of digital manipulation. The target data that you're looking for is sometimes scattered and hard to find. One of the critical aspects is trying to work smart here. And so if you are targeting an enemy IT infrastructure, it would be in your best interest to gain access to their security information and event management system, because that would save you a lot of time and allow you to get their perspective, which would help you in formulating an appropriate attack. Sometimes the data about the data, which is referred to as metadata, is more important than the actual data itself. As an analyst, you need to understand what it is that you are looking for in terms of, am I looking for a piece of information? Am I looking for what's happened to that information in terms of some parameters I'll talk about in a minute. There are three main types of metadata, as you see on this slide. And the metadata and the discovery of metadata is probably crucial to the analytical process. And as we look at the cyber side of the intelligence cycle versus the traditional side, on the traditional side, we use the int, SIGINT, COMINT, IMINT in particular, to determine the kinds of things that we look at from metadata. From a data forensics perspective, we look at metadata to find out when the data in question was created, when was it last accessed or modified, or deleted, and of course, who performed these actions, as well as what time the action was performed. In the more traditional domains, we use the collection method. So, for example, we might look at a warehouse with imagery and look at the vehicle traffic going in and out with imagery phased over time. Whereas if there is a database and a particular application, for example, let's say you were examining the personnel database of an enemy IT system to determine the level of manning and key personnel in your target. You would then have to use the metadata to determine who has access to the data. Because as I said before, the metadata shows you when the data was created, when it was last accessed or modified, deleted, etc. And once you determined who has access to the personnel file, you would then employ UMINT perhaps, or comment to learn more about that individual, and ultimately try and perhaps recruit that individual into your force, so that the metadata is indeed very important, and sometimes more important than the actual data itself. Another kind of metadata manipulation that we find is the use of simulations. Simulations can be used in a variety of ways, particularly if you have enough data to use as a foundation and to establish the kinds of patterns that you would be interested in. The Defense Department, as you see in this slide, is looking to establish an enterprise-wide cyber modeling and simulation capability. And it has to work with the intelligence community to develop the data schema, databases, algorithms, and so on. By having a modeling and simulation ability, you eliminate the need to work on live systems. You can do your modeling and simulation in parallel without disturbing the regular workflow, which is a great advantage in IT, because should you work with a live system and crash it, you have big time problems. A good example would be patching. We talked about the exploitation of vulnerabilities as a potential attack vector. We also talked about the fact that the way that organizations deal with the patching, with vulnerabilities rather, is patching. I mentioned that the patching process is not as simple as it would appear. Sometimes a new piece of code has an unintended effect because the underlying software is just so big. Consequently, by modeling or simulating the patch in another offline system, the organization can determine if there is a risk to putting that patch or not. Modeling and simulation is also very helpful in terms of nuclear, chemical, and biological weapons, whereby you can predict the impact of one of those weapons based on a big database that would include, among other things, weather, terrain, a number of people, water systems, and so on. So the use of simulation is parallel with big data. There are some strategic analysis challenges with respect to big data that flow from the functional challenges. Functional challenges on the previous slide included the need for a common lexicon, in other words, a description of the terminology and the processes. And there were two best practices identified by Carnegie Mellon to addressing those functional challenges, and that was comprehensive workflow to identify cyber threats and inform customers, and producing scripts to automate the filtration of known threat data. At the higher level, there is no industry standard for cyber intelligence and education and training. And there is sometimes a challenge to just leveraging and adapting traditional intelligence methodologies to the cyber landscape. The two best practices recommended by Carnegie Mellon here are to know your enemy and maintain global situation awareness. Now, global situation awareness is a pretty overarching term. I was on a project once with the CDC where we were developing a plan for the director of the CDC for global situation awareness, but that plan for the CDC focused on public health related events, things that happened around the world that were important to know because they might have a negative public health impact. This week's forum questions. The first one relates to the relationship of academia and the intelligence community. And how can academia assist in developing the state-of-the-art of cyber intelligence processing and analysis? The implication is that academia and to some extent the commercial sector are much more exposed to issues with respect to big data and can therefore make more appropriate contributions. And the second one, a second form question talks about if everything is data oriented and we have incredibly good analytical tools and we have incredibly good predictive tools, will this eliminate the need for human analysts? So I look forward to seeing your treatment of these questions. Next week, we're going to move on to another phase of the intelligence cycle, which is the dissemination phase. We will look at key characteristics of the cyber domain that impact dissemination, and we will review some of the dissemination failures in our history where the intelligence community might have had the intelligence they needed, but the dots were not connected or the intelligence work product was not provided to the right commander at the right time. We will also assess new possibilities and trends for dissemination, such as web-based services, mobile devices, and social media. And I think it's important to bear in mind that the end of this lesson represents halftime. Now, unfortunately, Lady Gaga and Beyonce were booked, so there won't be a halftime show. But I think it's appropriate to just look back and appreciate the dual-pronged nature of the course so far, where we've examined using the intelligence cycle against cyber targets, and we've looked at how technology is impacting the intelligence cycle itself. So we will continue assessing both of these in parallel. And I hope that during this lesson you have gained an understanding of big data, the classification types within it, and that my analysis of the marketplace for big data products and services was helpful. I hope that you have also taken an appreciation for how the metadata, in other words, the data about the data, can be more helpful to the analysis process rather than the data itself, and that we've addressed the various analytical types. I thank you for your kind attention, and I look forward to next week's lesson.